Hello, everyone. For this example, we'll use Workbench to analyze a similar building problem like the one we did with ANSYS APDL. As you can see on the screen, basically, I just opened Workbench. I changed my units into American system, customary, and I opened design. I opened first a static structural module, came up like this, and from that I'll do my geometry with design modeler. So here's my environment for the design modeler. And basically what I want to do at the beginning is to get some key points to build my geometry. One way of doing this is to go to create point, and basically I can add all these points that I want by giving the coordinates x, y, and z. An alternative way is to just read a file, a certain file that I already prepared for all these points. So that's what I will do. First, let me go back and change my dimension here. I want my dimension to be in foot. And the file, I'll show you the file I'm talking about. This is the file. And for any Workbench file that you need to read the coordinates of nodes, it has to have this format. A group number for all these points, a point number, and then the X, Y, Z. And all these fields are separated by space. So this is my file. So I'll go down here and recall this file from my directory to read those nodes. So I have it in this directory in here, and here's the file. I open it, and once I have that, I can generate these nodes. I'll zoom a little bit around them so that I can work with the system of nodes. I can move them also up a little bit. So these are the vertices, if you will, that will constitute my geometry. Next step is from these points, I'll draw some lines outlining the structure that I have. So I'll go to concept, and I'll do lines from points, and then one by one I'll start applying this by clicking on this node and Control key is pressed, so I get my first line, and then I'll just keep repeating this process as you can see in here. So I'm basically building my column lines, if you will, and you can see, I just built the columns, and I have a couple more down here. And this would be my last column. Then at the same procedure, I'll just add my elements, and they look in this direction like this. And also I have my lines in this direction. So every time just pick up a point and then you click Control, pick up the other point, that will give you a line. And on the other direction, I also want to get my lines similar to this one. I'm trying to keep all of them in the same direction. Not necessarily. And that will give me the basic module for these columns. Once I have all the lines, I can apply those and generate the line body that you can see in here. If you look down here, you find out that we need a cross section that will be used for this structure. So I can go in here at concept, I go to cross section, and for simplicity, I'll just choose a rectangular section. And again, I want my units to be in foot. So my column, I'll choose 1 foot by 1 foot, like this. So we can zoom. This is our section, looks like this. And it has a name, which is rectangular 1. And you can change the name by right click and you rename it with maybe a typical section. Or you can leave it as such. So basically, I created a section that I can go back to my line body in here and choose this section to represent that line element. My next step will be to generate surface bodies that will represent our slab for this building. So I can go again here to concept, and I choose surfaces from edges, and I'll go back and create those one by one. And notice here the sign that came out. It's kind of like a line with 2 dots, that little black sign that I'm highlighting like this. And this is important for us because this is basically picking up a line. As we will see, we can also pick up an edge of a surface. And that will be with kind of a different symbol. I want to be picking those edges as lines. So basically, this going again counterclockwise, that would be my first surface, which is coming here, so I can generate it, and then I keep going. Now you see, once I click on this guy, basically it gives me that cube and tells me that this line actually is the edge of the surface. I can go ahead and generate my surface as such, but then later on when we try to mesh this building, we might have a gap between the elements that are representing the beams and the elements that are representing the surface. So one way of like avoiding that as much as we can is to just to go to this surface that we just built and suppress it for now, so it won't appear on our plot. Then I'll add again, I'll just repeat this process with all the surfaces that I want to create. So here's another surface number 2. Just by control click and then apply, as well as I generate. Also at this point I can add the thickness of this particular one and I can generate it. So I have now surface number 2 as well. I can again, just for easier picking, I'll suppress it for now and I'll repeat the process. So this one will be like this. And again, I give my thickness of 1/2 foot and those edges that I picked, then I generate. I suppress and I add a new one. Make the thickness 1/2 foot and those edges that I picked, generate and suppress. My next one will be this one in here. Actually, for this one, I have to reset, so I can just start again. I want this to be one whole area, maybe like that. Just a little variation of what we had. I'll give it also a 0.5 foot, and I apply those lines that I did, and then I generate. And the last surface that I want to do is this one here. Again, it's 0.5 foot, and I'll apply those geometry that I picked, and I generate my surface. Now I can go back to this guy. I assign its thickness because I didn't do that in the beginning. And once I have that, then I can actually pick now all these surfaces and unsuppress them. So I have all my surfaces given like this. I'll apply later pressure on these surfaces, so I want to make sure that if I pick them, that green color will come, so that basically all the normals for these are as such. And if not, then you can go back here and change the surface normal. If this green color doesn't come, it means that it is upside down. then you can switch it in here. But consistently, because I went counterclockwise, then all of them came with the right normal that I wanted. So basically now I have this type of columns and beams and slabs. Let me break this surface also to 2, so I can just delete it like this, and then I can create another one. So I'm going to suppress all these one more time. Then I'll just make 2 slabs in here. So I can pick now another surface like that and make it also 0.5 and apply this geometry and generate. Then I'll suppress it for now, so I won't have to work with surface edges. And I go back and do the same thing one more time for this last surface in here. Make it 0.5 foot, 6 inches, and here is my surface. Then I generate. So now I have all the surfaces. I can go back again as I did and just unsuppress. And now I have my element or my structure with lines and surfaces like this. I want to make this as maybe a couple of story building. Then the way I do this is to go to create a pattern, and I'll pick up all these that I want to apply as to repeat for one more story. So basically I just will pick up everything by this box. So all these elements I want to replace, and the geometry here then will be apply. I choose a direction, which I can choose by choosing this edge. So basically I want to go in this direction, and I want that increment to be 12. I'll apply my direction that I just picked, and basically I'll generate. Then I created another story. Of course, if you want more than one, then you can add as many stories as you can. I'm just limiting myself for this example with just a couple, because this is an academic version of ANSYS that has a limit on nodes and elements that you can create. So I'm choosing only a couple of floors, but the idea would be the same if you want more stories than this one. From view, you can actually give some thickness to this structure that we have by going to view, and you highlight the cross-section solids. So basically, this is our geometry based on design modeler that we have. The next step will be to go to mechanical and analyze this geometry and create a finite element mesh and analyze it for different loads as we would like. Before before we do that, we can go back into our project, and I want for this structure to be as a concrete structure, not steel, which is the default. So I can go here and edit the engineering materials that I have. Then I can go here and choose the engineering data sources, and I click on general materials. So here's a list of pre-prepared materials that I can pick from. So I'll go up here and hit plus so that I can pick up a concrete material as well. If I go back to fill those sources, now you see the concrete in here and is given the properties of the material. So I added my material concrete, and then when I'll define my elements later in mechanical, I'll assign concrete for them. At this step now, I'm going to refresh my project. And once I have that, I can update the project, or I can simply just go now to mechanical. So I can create my finite element model, basically from that geometry that I created in design model. You can also create that geometry using space claim. So it's a matter of choice, and both will lead to the same results. It's a choice based on your level of comfort with which one. So here's my model. I have the geometry, and if you click on that, will have this guy. Now, if you look in here, all this is given as separate entities in here. So what I should have done is to go back to my design modeler, and out of those, all these bodies in here, I should choose all of them and create one part. So everything is connected together. So once I go back, I can update my geometry by update geometry from the source. So basically now I'll have this as one part only. Now you see a question mark point in here, and for the part also. And basically it tells me what the surface body, what material it is. So this is yellowed in here, and there's no material assigned with this part. So I can, from my pre-chosen material, I want to be concrete, so I just say concrete. So now all these marks are green now. So basically I have a concrete or reinforced concrete structure, and all slabs and columns and beams are made of concrete. My cross section is that typical section that I chose. And now it's time to do the mesh. So I can generate let the program generate the mesh for now, and then we might need to go back and work on it. So here's our mesh. And for now, we'll just work with this mesh, and it might not give me the right answers that I'm looking for. But let's just go through it, and then we'll see if it doesn't work, how we can fix it. So now I want, again, everything is done so far. I want to go to my analysis settings, static structure. Once I hit that, then I have items that I can add in terms of supports or inertial loads or pressures and so forth. So I'll just change this view into a front view like this, and I'll apply just to give it some look like this. So basically, I just went back to the view and I showed the cross, the solid cross section here, so you can see it a little bit better. And I'm gonna apply supports, and I want to fix all the points down here. So I'll choose point, and I'll pick all the points that I want to choose from here. So all of them are highlighted, and in the background, all other nodes also were picked. You can see them in here. So all these points are fixed now. I'll say apply. Now all these points are fixed. Then I will add my inertial load. So my y-axis is the vertical one. So I go down here and change this to -y direction, and the material already is defined with density. So that will be applied by the gravitational acceleration, and this in inches per second squared. And in Workbench, unlike APDL, you can switch back and forth a little bit with the units, and the program will take care of it. So we give the dimensions in foot, and here we have the acceleration in inches. You can go back to units and change if you want, but for now, we'll just keep it as such. And then the next step will be to apply some loads on these surfaces that we have. So we can go to loads, pressure. I can pick up again all these surfaces like this, and all of them are green, which means that the normal is in the positive y direction. I didn't have to flip any of those normals, and I'll apply a certain pressure. So I want now to make my units as foot. So I apply about 100 pounds per square foot. And for my selection, which I highlighted, I can say apply, and I have 14 slabs similar to this one. So now everything is set to run my analysis. I'm gonna choose some of those results that I want to look at. So I can choose a total deflection. I can choose also a deflection in a certain direction. So you go back here and choose maybe the vertical direction for now. Then we can also choose other quantities that we want. So in terms of stresses, we can look at maximum principal stress. We can look at minimum principal stress. We can also add normal stress and shear stress. Of course, you can add as many as you want. And another very useful result that we can get, you get it from rope, and you can get actually force reaction. And it asks you where you want this reaction. So basically we pick up the fixed support that we chose, and also we can insert another probe for the moment reaction. Again, it asks you here where do you want it at the fixed support. And you can also add a beam tool, which gives you some values as well in here, like this. So let's try this for now, and then we'll see what will happen. Basically, I have everything set. I just hit solve. So now the program is working on solving this problem. And I can look at my results. So now here the trouble. Basically what this tells me that actually this slab just went away from this beams that's supposed to support it. In some other areas it's okay, but down here there was some gap between this guy and this beam, and we don't want that. So basically what we can do to fix this is go back to our mesh. It looks like it is connected, but actually it wasn't. So to fix this, basically I can go in here for the mesh and insert node merge group. What this will do is to pick up all these nodes that are close to each other within a tolerance that I specify. So I have to be careful also not to have a very big tolerance that it might actually create elements that I don't need or disturb some elements that are already there. So I'll pick up 0.1. I knew that my size was 0.5, so 0.1 should be okay. And then I pick up all these nodes here within the geometry to merge whatever closer nodes in this slab and this beam together. So I can resolve this problem after I added those merge of the nodes. And now if I look, now this looks a better distribution of the deformations that I have, and everything is connected, and I see the maximum deflection down here. And I can look at my other quantities that I pre-selected to look at. As you can see. Then I can also look at the reaction forces. I can read their numbers in here and the moment reactions as well. And I can look at the beam stresses, and I can also look at the combined stress and the maximum stress. So all these are available in my results. If you want to plot a bending moment diagram or a shear diagram for some of these elements, there is a way to do that. And basically in here, we can go back to a model, and we can insert what we call a construction geometry. So basically, that construction geometry, I can insert a path similar to this one. And from the path type in here, I choose edge. And with control, I can choose my edges. Say I want to look at this beam like this. Then I apply. So this is my beam that I look at. And then in the results down here, I can add a shear moment diagram, and it will tell me in here I have to relate this to this path I chose in the beginning. And once I have this set up, I can solve for it, and that basically will give you the distribution of the moments and shears and the displacement along this line. So basically what we did is to analyze a building similar maybe to the one I showed you earlier on a different example with APDL. We can do the same thing with Workbench. Also, there is a connection between Workbench and APDL. You can go back here and from tools, write an input file and you give it a certain name. So let's call it building, say 3, and you place it at whatever directory you choose, and you can save this file. And basically this file is a text file that you can use to read directly into APDL. This file will be helpful if you want to change some of the parameters or some of the beam types or material types in a text file. So with that, I conclude this example, and if you have any questions, we can discuss them in our regular lecture meeting. Thanks for listening and take